Hi, good morning dear students. Welcome back to chemistry class. In the last class we have completed Faraday's first law, second law and numericals on it. So in today's session we are moving to the next concept, that is some commercial cells or batteries. Take the next heading, some commercial cells. Commercial cells, or we can call batteries. As we have studied about galvanic cell, right? What is meant by cell? Cell is nothing but it containing two half cells, oxidation half cell and reduction half cell. When it is connected by using salt bridge and connecting wires, we can call a cell. Now, here batteries, commercial cells. Batteries is nothing but it is an arrangement of two or more cells. Batteries is nothing but it is a arrangement of two or more cells together we can call it as batteries, and which is used to get the direct current, direct electric current, used as a source of current is known as batteries. So here the definition of battery, battery is an arrangement of two or more cells, galvanic cells, which is used as a source of direct electric current at constant voltage. Voltage constant आना चाहिए वहां पर. तो इसके definitions आप नोट कर सकते हैं. It is an arrangement of two or more cells, two or more galvanic cells, which is used as a source of direct electric current, at constant voltage. Simple है यहाँ पर. Just batteries is nothing but two or more galvanic cells को connect किया है and which is used as a source of energy. यहाँ पर constant voltage आना चाहिए. This is we can call as batteries, or commonly known as some commercial cells बोल सकते हैं इसको. And here an useful battery is one which must and should fulfill some of the requirements. अब बहुत सारे batteries हैं. All the batteries are useful है या नहीं? The useful batteries are those which must and should fulfill some of the requirements. Batteries बोले तो कैसा रहना चाहिए? Number first point, it should be light and compact. इसका मतलब है it can be easily transported. ट्रांसपोर्टेबल रहना चाहिए, लाइट एंड कॉम्पैक्ट रहना चाहिए, एंड उसका जो लाइफ है इट मस्ट एंड शुड हैव अ रीजनेबली लॉन्ग लाइफ रहना चाहिए उसका, लॉन्ग लाइफ. बीइंग इन यूज्ड और बीइंग नॉट यूज्ड, when the batteries are being in used or when it is not in used, it must and should have a long life. And the one more important requirement is it must and should have produce constant voltage. Variable voltage नहीं आना चाहिए, constant voltage आना चाहिए. And useful batteries must and should, देखिए useful batteries should satisfy these requirements. It must be light and compact रहना चाहिए. It must be light and compact. So therefore it can be easily transported. Whereas the second one, it is light and compact food. Next क्या है? It should have reasonably high are reasonably have long life when being in use or when it is not in use. लॉन्ग लाइफ रहना चाहिए, लाइट रहना चाहिए, कॉम्पैक्ट रहना चाहिए एंड it should produce voltage. कैसा रहना चाहिए वो? Constant voltage. It should produce a constant voltage. These are the some of requirements for a battery. Light and compact, long life रहना चाहिए and it mustn't produce a constant voltage. So these are the some requirements for an useful battery. Now here these batteries are mainly two types of batteries. यहाँ पर दो types है. Number one, primary batteries. Primary batteries are primary cells, and the second one is secondary cell. Primary and secondary. Primary and second one secondary. Primary cell and secondary cell. देखिए, in our day-to-day life, we have used so many batteries. Among that, some of the batteries are rechargeable batteries and some of are not rechargeable. एक बार यूज किया तो फेंक देते हो. The batteries which cannot be recharged again. The batteries are the cells in which the electrode reaction takes place only once, which cannot be reversed. Such batteries are called as primary cells or primary batteries. Since the electrode reaction cannot be reversed, these cannot be recharged. It cannot be charged by some external source of current. इसको हम primary cells बोलते हैं. Whereas secondary cells are those in which the electrode reaction can be reversed by the help of an external source. Rechargeable batteries are called as secondary cells. So simple यहाँ पर primary cells or primary batteries are those in which these are the cells in which electrode reaction takes place only once. Electrode reaction cannot be reversed. Electrode reaction cannot be reversed by using an external source of current. करंट सप्लाई किया तो इलेक्ट्रोड रिएक्शन रिवर्स नहीं होते हैं. By using the external source we cannot reverse the electrode reaction, therefore these are not chargeable. Or these are not chargeable, and once if it is used they become dead. These are known as primary cells. Here examples में dry cell and mercury cell. These two we are going to study, dry cell and mercury cell. Whereas secondary cells are those cells in which electrode reactions can be reversed. Electrode reaction can be reversed. Electrode reaction can be reversed with the external source of energy. With the external source of energy, we can change the electrode reaction. That means therefore these are called as, they can be chargeable battery से ये example में lead storage battery, lead storage cell, lead storage, and nickel cadmium storage cells. This is about primary and secondary batteries. देखिए यहाँ क्या है, commercial cells, batteries means what? It's an arrangement of two or more galvanic cells which is used as a source of direct electric current at constant voltage. ये definition हुआ battery का. And a useful battery must and should have satisfy these requirements. कैसा? They must be light and compact रहना चाहिए. Therefore, they can easily transported, and it should have long life. Being in use or in not used. हम यूज जब यूज करते हैं, नहीं तो यूज नहीं किया तो उसका लाइफ लॉन्ग रहना चाहिए. एंड इट शुड प्रोड्यूस ए कांस्टेंट वोल्टेज रहना चाहिए. एंड देयर आर टू टाइप्स ऑफ बैटरीज, प्राइमरी एंड सेकेंडरी बैटरीज. आफ्टर द प्राइमरी एंड सेकेंडरी बैटरीज, नाउ वी आर मूविंग इन डिटेल ऑफ प्राइमरी एंड सेकेंडरी बैटरीज. सो प्राइमरी बैटरी में कौन सा है? In the primary batteries, dry cell and mercury cell, whereas examples of secondary batteries में lead storage and nickel cadmium batteries है. Now let us consider the first one, that is dry cell. Primary batteries में first example कौन सा है? Dry cell. So it is also known as Leclanche cells. Because this is invented by G. Leclanche, so it is also known as Leclanche cell. So here, not only in this case, in all the four cases में, that is primary batteries and secondary batteries में दो examples है. हर केस में which one is anode, which one is cathode, which electrolyte is used, what is the anode reaction, cathode reaction and overall reactions हमको practice करना पड़ेगा. Now let us come to the first one, dry cell. So what is meant by dry cell? How it is constructed? What are the reactions? What is its voltage? उसके बारे में थोड़ा देखेंगे. Now first one is Leclanche cell or dry cell. Dry cell it consists of, देखिए यहाँ पर dry cell में it consists of a zinc cylinder. This is zinc cylinder है. And it is filled with an electrolyte, zinc chloride and ammonium chloride. Electrolyte is filled in this, and a graphite rod is surrounded by a black paste of manganese oxide and carbon powder is dipped in it. ये graphite rod है which act as a cathode. Dry cell consists of zinc cylinder which act as anode. Zinc cylinder है which act as anode, and it contains a paste of NH4Cl plus ZnCl2, zinc chloride and ammonium chloride का paste है. This act as an electrolyte. ये यहाँ पर electrolyte है, and this is graphite. ये graphite rod है. Graphite rod surrounded by a paste of manganese oxide and carbon powder. This act as cathode. It act as cathode. So यहाँ पर ये जो graphite rod है, this is surrounded by a black paste of manganese oxide and carbon powder, and remaining it is a paste of this. This is a paste of electrolyte. तो ये हुआ इसका कंस्ट्रक्शन, ड्राई सेल है ये. तो देखिए यहाँ पर What are the reactions? Cell reactions क्या है? यहाँ पर क्या है? प्रोसीजर क्या है? Zinc act as an anode. Anode बोले तो कौन सा रिएक्शन? ऑक्सीडेशन. तो जिंक अंडरगोइंग ऑक्सीडेशन. ऑक्सीडेशन बोले तो क्या होते हैं यहाँ पर? डिसॉल्व्स. So Zn2 plus ions which dissolves in the electrolyte. Electrolyte में NH4 plus and zinc chloride है. So these electrons are transferred to the cathode where the NH4 plus ion get discharged. यहाँ पर डिस्चार्ज होते हैं. MnO2 ये जो इलेक्ट्रोलाइट पेस्ट दिया है पर इट्स सराउंडेड बाय मैंगनीज ऑक्साइड एंड कार्बन व्हिच हेल्प्स और व्हिच एक्ट एज एन इलेक्ट्रोलाइट, वो भी इलेक्ट्रोलाइट है क्योंकि कैथोड एनोड एंड रिमाइनिंग यहाँ पर इलेक्ट्रोलाइट है। नाउ एट एनोड लुक एट द सेल रिएक्शन, तीन रिएक्शन ओवरऑल रिएक्शंस नोट करना पड़ेगा एट एनोड। एनोड बोले तो कंपलसरी ऑक्सीडेशन होना चाहिए, आपको पता है। एट एनोड zinc undergoing oxidation, it gives to zinc ion plus 2 electrons. So we can say that here outer zinc cylinder जो है, zinc cylinder undergo oxidation or it dissolves, Zn2 plus ions electrolyte में गए यहाँ पर, it dissolves। तो ये एक पॉइंट हुआ यहाँ पर। यहाँ पर जो इलेक्ट्रॉन्स लिबरेट हो रहे वो इलेक्ट्रॉन्स थ्रू द सर्क्यूट लास्ट ये पर क्या पर मेटालिक कैप रहते हैं इसके ऊपर, क्योंकि सेल के ऊपर आप बैटरीज के ऊपर देख सकते हैं एक मेटालिक कैप रहता है। एंड अगर वो कंप्लीट ओपन करके देखे तो इट इज ए जिंक सिलेंडर एंड इवन नाउअडेज इट मे बी एन आयरन का रह सकते हैं, आयरन सिलेंडर रह सकते हैं ये, इवन सिल्वर और लिथियम का भी बनाया हुआ रहता है। एंड दिस वन सेंटर क्या रहता है, एक ग्राफाइट रॉड रहता है, ब्लैक पेस्ट रहते हैं सराउंडिंग में, मैंगनीज ऑक्साइड एंड कार्बन पाउडर रहते हैं वहां पर। सो ये एक ऑक्सीडेशन रिएक्शन हुआ। नेक्स्ट एट कैथोड, कैथोड में कौन क्या होना चाहिए, एट कैथोड रिडक्शन रिएक्शन टेक्स प्लेस। रिडक्शन मींस गेन ऑफ इलेक्ट्रॉन, तो ये NH4 प्लस आयंस है, 2 molecules of NH4 plus ions in the presence of MnO2 which gains the electrons and gives rise to manganese Mn hydroxide MnOOH plus MnOOH plus 2 to the 4 MnOOH plus 2 NH3 molecules MnOOH plus 2 NH3। तो ये रिएक्शंस आ गए आपको। NH3 इज ए गैस, गैस इज लिबरेटेड इन दिस केस। द ओवरऑल रिएक्शन इज, ओवरऑल रिएक्शन क्या होता है देखिए यहाँ पर ओवरऑल रिएक्शन 2 इलेक्ट्रॉन्स गेट कैंसल्स, 2 इलेक्ट्रॉन कैंसिल हुआ, तो यहाँ पर हम लिख सकते हैं Zn प्लस 2 molecules of NH4 plus MnO2 which gives rise to Zn2 plus 2 molecules of MnOOH plus 2 NH3 plus 2 NH3. So this is the reaction. This is the overall reactions where we can say that zinc undergoing oxidation and ammonium ions undergoing reductions, because these NH4 plus ions which get discharged at the cathode and NH3 gas is liberated। देखिए यहाँ पर अगर ये गैस ऐसा ही अंदर रहा तो it may there is a chance of cracking of the batteries। So here the liberated NH3 which converted into a coordination complex by using zinc chloride। यहाँ पर तो जिंक क्लोराइड यूज किया, इसका काम क्या है, ZnCl2 जिंक क्लोराइड क्या है यहाँ पर, इट अब्सॉर्ब्स द लिबरेटेड NH3 and it forms a coordination complex। अगर ये NH3 यहाँ पर अब्सॉर्ब नहीं हुआ तो गैस लिबरेट हुआ है, उसका प्रेशर ज्यादा हो जाएगा, देयर मे चांसेस ऑफ क्रैकिंग ऑफ द बैटरीज। सो इन ऑर्डर टू अवॉइड दैट वी आर यूजिंग द जिंक क्लोराइड। इसका काम क्या है, which absorbs the liberated ammonia gas and it forms a coordination complex फॉर्म हुआ तो प्रेशर कम हुआ, there is no cracking in the batteries। तो ये हुआ आपका रिएक्शन प्राइमरी सेल्स के बारे में, प्राइमरी सेल। एंड इन दिस केस द वोल्टेज ऑफ दिस बैटरी इज अराउंड 1.5 to 1.2 to 1.5 volt of battery, in this battery 1.2 to 1.5 volt of current is generated in this case। This is the capacity of this primary batteries। Particular example dry cell का capacity कितना है, 1.2 to 1.5 volt है। And in this case zinc cylinder act as anode, graphite rod act as cathode, and here the electrolyte used is NH4Cl and ZnCl2। ZnCl2 का काम क्या है, it makes a coordination compound with the liberated ammonia gas. The ammonia gas is liberated at cathode. So this is about the dry cell. Now let us consider the second example, that is mercury cell. Mercury cell. Note कीजिए, second one is mercury cell. In mercury cell is also simple, same रहता है यहाँ पर भी mercury cell में भी. In the mercury cell, zinc amalgam or zinc act as an anode, mercuric oxide act as an cathode, and here potassium hydroxide which act as an electrolyte. The second example, second one is, first one dry cell हुआ, second one is mercury cell. So in this mercury cell, here zinc act as an anode. In this case, anode, cathode, and electrolyte. Anodes, यहाँ पर zinc act as an anode or zinc amalgam act as an anode. Mercury 2 oxide, that is HgO, act as a cathode. Electrolyte is a paste of potassium hydroxide and zinc oxide which act as an electrolyte. तो एनोड कौन सा है, कैथोड कौन सा है, इलेक्ट्रोलाइट कौन सा है. तो ये होने के बाद और 3 पॉइंट आपको चाहिए. एनोड रिएक्शन कौन सा है यहाँ पर, जिंक एट एनोड ऑक्सीडेशन अकर. ऑक्सीडेशन यहाँ पर जिंक जो है, जिंक अंडरगोइंग ऑक्सीडेशन, दिस गिव्स राइज टू Zn2 plus 2 इलेक्ट्रॉन्स. यहाँ पर आ गया Zn2 plus 2 इलेक्ट्रॉन. अगर हम डायरेक्टली नहीं लिखते तो यू कैन यूज द इलेक्ट्रोलाइट, क्योंकि इन द प्रेजेंस ऑफ इलेक्ट्रोलाइट द रिएक्शन इज टेकिंग प्लेस. और डायरेक्टली अगर इलेक्ट्रोलाइट यूज करके अगर हम यहाँ पर लिखे तो जिंक अमलगम, दिस इन द प्रेजेंस ऑफ एन इलेक्ट्रोलाइट OH minus gives rise to zinc oxide plus H2O plus electron. Electrons are liberated in this case. You can check it. Zinc is in +2 state. ऑक्सीडेशन हुआ है, ऑक्सीडेशन हो गया यहाँ पर. नेक्स्ट एट कैथोड के केस में क्या होता है, यहाँ पर कैथोड मींस रिडक्शन है. रिडक्शन HgO undergoing reduction in the presence of H2O plus 2 electron. This gives rise to mercury gets separated plus 2 OH minus ions are formed. The overall reaction in this case is, overall reaction देखिए, 2 OH get cancels, 2 electrons get cancels, और बचा क्या है यहाँ पर, H2O also get cancels. The remaining is zinc when it is treated with HgO, zinc and HgO. This gives rise to zinc oxide plus Hg, zinc oxide plus Hg. So the overall reaction do not involve any electrolytic ions. So directly anode and cathode का reaction है यहाँ पर, zinc undergoing oxidation and mercury undergoing reduction. So here in this cell the voltage, cell potential is 1.35 volt. 1.35 volt of current is generated in the mercury cell. This is about dry cell and mercury cell, which comes in primary batteries. In the next class we'll discuss about the secondary batteries. Secondary batteries में दो है, lead storage and nickel cadmium storage. वो दोनों next class में complete करेंगे.